In this video, we're going to integrate x over the square root of 1 plus x squared on the interval 0 to 1. And the first approach I'll take to this is the informal approach, where we're basically recognizing how to do the chain rule backwards. And it helps to rewrite this thing as x times 1 plus x squared all raised to the negative 1/2 power. This allows us to see the integral as a composite function sitting right next to the derivative of the interior of that composite function, which is what the chain rule does. Now the derivative of the interior is actually 2x, not just x, but we can throw a factor of 2 inside as long as we put a 1/2 outside to compensate for it. And now I can just use the power rule for antiderivatives to write the antiderivative here as a 1 plus x squared to the 1/2, that's just adding 1 to the exponent, divided by 1/2. And this is all evaluated from 0 to 1. Now the 1/2 in the denominator cancels the 1/2 out in front. And then when I sub in my upper limit of integration, I get a 2 to the 1/2. And when I sub in my lower limit of integration, I get a 1 to the 1/2, or just 1. And this all cleans up to root 2 minus 1, and we're done. The more formal approach to this is to do a u substitution. And that's basically where we give a name to the interior of the composite function. And then we still need to find the derivative of that floating around in the integral. And then when it comes to using the power rule to get the antiderivative, things look a little bit cleaner. So we let u equal the 1 plus x squared. And again, if you're not seeing the derivative of u somewhere else in the integral, this kind of substitution isn't going to work for you. And I get a du equals 2x dx. And so just backing up to our original expression for the integral, that was an x over square root 1 plus x squared dx. And so that denominator is a square root of u. And then I need to find 2x dx, so I just tack on a factor of 2 in the numerator, put a 1/2 out in front, same thing we did before. Now this can be reworked entirely in terms of u, and I'm going to make a note here that our limits of integration are x limits of integration, and our integral is du over the square root of u. Now we have an option here at this point. We could transform our limits of integration into u space, or we could decide that at the end of the integral, we're going to transform the antiderivative back to x space before we apply these limits of integration. I have a preference for transforming the limits of integration. And so I'm going to say when x is 0, I go back to the definition of u. I can see when x is 0, u is 1. And then when x is 1, plugging in x equals 1 there, I get u equals 2. So now this integral can be written as 1/2. And then the integral as u goes from 1 to 2. And then I'll write 1 over the square root of u as a u to the negative 1/2. Using the power rule for antiderivatives, I get u to the 1/2 divided by 1/2. And again, the 1/2s cancel each other. And I'm evaluating this thing from 1 to 2. And I plug in the upper limit and get 2 to the 1/2, or square root 2. Plug in the lower limit and I get a 1. So I get a square root of 2 minus 1. And we get to the same answer. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left. Or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.